differentiate on. There are two methods that we can use to find the exact value for the slope of a tangent line at a given point, x equals a. Or I could just say to find the derivative at a. And one of them uses this limit method, and the other one uses this limit method. So what we're going to look at today is, I use it a little bit better, is we are going to look at how do you find a general version of this? Because up to now, we've just been finding f-1 and f-2 and numbers, right? It's been typically numbers there. But what happens if you just leave that as an a? How do you do that? So that's the first thing we're going to do. And then we're going to look at calculating average velocities, and then how to calculate technically you call them instantaneous velocity, but most of the time we drop the word instantaneous. We just say velocity and acceleration. So these two are going to be used as like an application of one of the very many things you can do with derivatives. Right, so return back to the first one. So suppose I have a function and it's 2 square root of x. And I wanted to know a lot of different derivatives. I'd like to know the slope when it's 1, the slope when it was 4, the slope when it was, say, 100, right? If I gave you 3 separate questions, if we were using yesterday's technique, wouldn't I have to choose either this one or this one and do it 3 times, right? Do it once to get that answer, do it a second time to get that answer, do it a third time to get that answer. Wouldn't it be more efficient just to find out what that was? In other words, get a formula, it'll be in terms of a, of course, for the derivative of a. And then once I've got that formula, can't I just put 1 into it, then 4 into it, and then 100 into it, and I'll save a bit of time, right? So that's the motivation behind why I would want to find a general derivative f dash of a, rather than one with a specific number inside of it. The good news is that the method is pretty much yesterday. A little bit less numbers, a little bit more letters. That's the only difference. So since it's 2 square root of x, do you want me to use the top one? Or do you want me to use the bottom one?
Top one, polynomial.
We'll do it as a polynomial, okay. So it's going to be the limit as h tends to 0 of the function at a plus h, take away the function at a all over h. Okay. I'm probably going to move this into 2 pages, but that's fine. It's the limit as h tends to 0. Now, since this is my formula, my f of x, if I want to find f of a plus h, don't we just replace the x with a plus h? No biggie. So 2 lots of the square root of a plus h, take away. Since this is f of x, if I want to find f of a, don't I just replace the x by a, and you get take away 2 square root of a all over h. We all comfortable with that? Mostly letters, not many numbers, but math doesn't really care if it's a letter or number. We manipulate things in very similar ways. Now I just realized, so I might as well start over here, that I need more room. So I'm just rewriting that last line. So you don't need to do anything. Just need to wait for me. Sometimes my A's start looking like 9s. So if it looks like a 9, it's an A, right? Do you recognize that this question involves a conjugate method? And we have square roots, that's the clue. And the conjugate of this guy is the same 2 fellas, but with a plus. So 2 lots of the square root of a plus h, add 2 square root of a. 2 lots of the square root of a plus h, add to square root of a. So far, so good. Now, the bottom two terms, although they're pretty ugly, I just rewrite them. Don't multiply them together, don't do anything. Just rewrite them as they are. And the top two terms get multiplied out, right? We FOIL them. And I could do a bit of scratch paper and FOIL them, and I would get the right answer, but I'm going to use the shortcut. And the shortcut says that when you do a conjugate method and you multiply something with its conjugate, you get the first thing squared, take away the second thing squared. So I just have to make sure that I square this guy here correctly, and then I take away what you get when you square this guy. Now, if you take, cover up everything that doesn't matter. If you take 2 square root of a's and you multiply it by 2 square root of a plus h's, right? So you do it the same guy twice, you will get 4 lots of a plus h. You comfortable with the 2 2's get you the 4 and the square roots get you a plus h. Now a little bit easier on the second one, take away this guy squared and you get 4a. Everything looking good? Right. So we move on to the next step. Don't do anything to the bottom, ever. Distribute 4a plus 4h, take away 4a. And something really nice should happen. Algebraically, something really nice did happen. Don't I just get left with 4h? Right, the 4a and the minus 4a cancel that. Which means, oops, I've forgotten, I'll put it here. All the way through this, hasn't there been this limit as h tends to 0? It's not really done anything yet, hasn't had a job to do, but it is there. Okay. What should I do now? We got to here. What should I do now? Yeah, a 1-for-1 deal. So I now have the limit as h tends to 0 of 4 over 2 lots of the square root of a plus h plus 2 lots of the square root of a. Okay, and that's a 0 anyway. Let's plug in h as 0 now. So it's going to be...
You can also divide it by 2, but I think that's overkill.
Oh no, I like it, and we will divide by 2. Could have done it right at the start. Nothing wrong with that, I like it. You're going to get 2 square root of a's plus 2 square root of a's, right? Okay. A plus nothing is just a, right? So you get 2 square root of a's plus 2 square root of a's. Now we're on to what I call style points. Style points, make it look pretty. Well, on the bottom, I've got 2 square root of a's plus another 2 square root of a's. Doesn't that get me 4 square root of a's? 2 of these guys plus another 2. I get 4 of them. Can I make it even prettier than that? Is there anything you can do to simplify this?
Yeah, so you get rid of the 4s.
Okay, cancel 1-for-1.
And then you multiply by square root of a over square root of a.
Okay, so we call that rationalizing the denominator. And there you go. The general derivative, f dashed of a, is the square root of a over a. Now let's go back to my original question, where we're going to use this function, right? The one we started with, and we're now going to find the derivative at 1. Well, won't that just be the square root of 1 over 1? So that answer would be 1. And when you do 4, it's going to be what? The square root of 4 over 4. 2 over 4 gets you half. You want the square root of 100 now? Sorry, you want the derivative at 100? It's the square root of 100 over 10, which ends up being 1. Now, once you've got that general derivative, can't I find the slope of the tangent line to this curve at any value of x I like?
Why is it over 10?
Uh-oh. There you go.
All right.
So you had to do more awkward work up front, but isn't it worth it at the end? Because you now have a way of calculating any derivative at any given value. All you do is replace the a by 1 or 4, and be careful when I wasn't, or 100. Could I have taken that same question and used this instead of the one I did use, which was the top one? Could I have got the answer by using this? Yeah. It probably would have looked slightly nicer, slightly easier to do, but, it's not the end of the world. Got the answer. Okay, do another one of those F-A questions. I'm going to see if I can find one. They're down at the bottom, if I remember. There they are. Okay. So this is a version of question 15. And the function is a quadratic. So it's 2x squared, take away 3x plus 1. And they only ask you to find that, right? So we're not going to have an extra bit where they find the numbers. I think it would have been nice if they gave you, find this, and find this as well, but they didn't. So that's okay. We get a chance to do that next anyway, so it's not a biggie. You could use either method. And for a quadratic, it doesn't really matter. The math isn't that much different. But if that had been 2x cubed, for instance, please use the top one. Just trust me, you do not want to do it with this one. The algebra is scary, right? So anything that's a polynomial in general, you should use the top one. For quadratics, it's not a biggie because the work is about the same. But after quadratics, this definitely makes a difference, right? And fractions, 4 over x plus 2, that kind of thing, I suggest strongly that you use this. Makes the math a little bit easier. So since we're going to do the top one again, it's going to be the limit as h tends to 0 of f of a plus h, take away f of a all over h. So it's going to be the limit as h tends to 0. Okay, this is f of x. If you want to find the value of the function at a plus h, this and this gets replaced by a plus h. So you have 2 lots of a plus h squared, take away 3 lots of a plus h, add 1. And I am about to do a deliberate mistake. Take away f of a. Well, just replace a's here. That is a mistake. What have I forgotten to do?
Didn't distribute the negative.
So the easiest way to remember that right now is just stick a bracket around it. Aren't you subtracting all of f of a? Before I put those brackets in, I was only subtracting the first term. The other two were unchanged. So let's continue then with our next line. If you FOIL this guy out, you will get an a squared, a 2ah, and an h squared. You distribute the 3, you will get that, and you get a plus 1. And then you're going to take away 2a squared, take away negative 3a, so let's add 3a, and take away 1. So far, so good. Right. If I'd thought ahead, which I didn't, shouldn't have doubled this while I was foiling it. But since I forgot to do that, I'm going to have to do it in this line. So it's 2a squared, 4ah's, 2h squareds, minus a 3a, minus a 3h, plus a 1, and all this other stuff. And that's a pretty ugly looking top row, right? There's tons of things going on here. So we call this collecting like terms. And sometimes I think of this as a battle, and things get killed by other things. Eliminated, killed. Tell me something that gets killed off by something else.
The 3A's.
Okay, that one gets killed by that one. Anything else getting killed here?
2A squared. Yeah.
That one gets killed by that one. Anything else getting killed here?
1.
That's a pretty violent war, wasn't it? A lot of things get killed. I think it's because I'm from Scotland and we tend to think of things in terms of violence. So here it goes. I have that guy left, that guy left, and that guy left. Right, that's it. Now, I'm pausing at this point because this is good news. Whenever you do this method, right, the H on the bottom one, right, this guy, and you do it with a polynomial, once you've gone through all the algebra and you've, collected like terms, anything that's on the top must have an H in it. May have H squareds and other stuff, but it must have at least an H. If you have a plus 2a left over or a minus 7 left over, right? Something that doesn't have an H in it, stop. You have screwed up. Somewhere between here and here, you forgot to multiply something by 2, or a plus turned into a minus that it shouldn't have, right? Something is wrong, because it must always be H's in every term. So that's a nice place to do a kind of, okay, does it look like I'm on form here to do this correctly? Right, so kind of pause at this point here. I like this. Do you see they're all H's? I'm happy that I'm probably in the right place. The next line, when you're doing at least polynomials, typically the same line. You pull out a common factor of H from the numerator. And since the top line is always going to have at least one H, isn't that always going to happen? And once you've done this, I hope you recognize that you can cancel 1 for 1. And now we're left with the limit as H tends to 0 of this guy plus this guy, take away 3. Right. You could say technically over 1, but over 1 just means you're not a fraction anymore. Right, you're just an expression. At this point, can't we then plug in 0? So you will get 4a plus 2 lots of 0 take away 3. And your answer then is 4a take away 3. We have found the general derivative that they asked us to. Any questions? You feel good about the process? Would you agree it's really just yesterday, but with less numbers? Right. Same thing as yesterday, but just with less numbers. So let's move on to the second thing on my list. How to find average velocity. I think there's only one example of that, so I'll probably pick it because it makes my life easy. Where the heck are you? Oh, here we are. There's a question 8 where you're told the position of an object. So this is called the position function, and it happens to be 1/2 t squared take away 7t plus 17, and we're being asked to find the average velocity. And then they give us intervals. They give us intervals like from 4 to 8. So that's an example of being asked to find an average velocity. Let me show you the general formula that we're going to use then. So for any function, let's call it f of x. If you want to find its average velocity, from A to B, then you'll see it look in a lot of textbook as FAVV, just for average. It's the value of the function at B, take away the value of the function at A, divided by B, take away A. That's all it is. So now I'm going to look at that question. So I want to find the average velocity from 4 to 8. I'm going to find the value of the function at 8, take away the value of the function at 4, and divide it by 8, take away 4. I want you to think of that as the A and the B, right? You see it? S of A, S of B, A. No, actually B, A, B, A. Now that's easy to do. That's a little bit messier, so I'm just going to let the calculator do it, especially if I know I'm going to be doing it a lot of times. So I'll go into the calculator and I'll type in 1/2, so I'll just call it 0. Oops, I'll call it 0.5x squared. Damn it, that is it. 0.5x squared. Take away 7x's. Add 17. Okay. I know it says x's, but x's, t's, b's, nobody cares, right? Math, it's just a placeholder for a value. So 1/2 x squared minus 7x plus 17 is essentially that guy. I've already set up the table from all sorts of other questions, so I'm put in what do I need to know? 8. And the answer to that is -7. Take away 4. And the answer to that is -3. So -7 add 3 gets me -4. -4 over 4 is -1. Are you comfortable about how to get the average value then? Now, if they change the number, let's do one more. Let's suppose they want to know the average value from 8 to 10. I'm just randomly picking start and finish. That's like my A, that's like my B. I want to know the average velocity on this moving object from 8 to 10 seconds. So it would be the position at the 10-second mark, take away its position at the 8-second mark, divided by how many seconds had passed. And S of 10 is 13. S of 8, actually I already know S of 8, but it's too late now, so there we go. And the bottom is 2. 13 add that is 20, 20 over 2. And the average in this case would be 10. Are you comfortable with that then? I can keep doing it, but I don't think I need to, right? So, average velocity. Average velocity. And it's only the average velocity because this function is representing position, right? It would be average rate of change if you wanted to make it very general, right? Because maybe the next time this function is voltage. And so it would be the average rate of change of the voltage. Or maybe next time it's a temperature, in which case this would be telling you the rate of change of temperature, right? How temperature was changing through time, right? It's just velocity because it happens to be the position function. And then they finish with this term.
Yes, sir. For the last one, I got 2 as the answer for 8, 10.
Which one did you get?
I got 2
2.
as the final answer instead of 10.
Because I can't count?
I
Let's check.
believe x of 10 is -3, not 13.
It is. That's going to be 4. It's going to be 2. Right, I'm going to hold on a second.
You broke Donald.
Okay, maybe I can start seeing better. I got one good eye and quite a dirty screen as well. Maybe that's part of my problem. Yeah, it clearly is -3, although my brain didn't see that. Hopefully that's not a big distraction. Would you agree? It's just be careful. Now, they're asking us to find a thing called instantaneous velocity. Can you imagine that you are driving a car and you're not driving at a constant velocity, right? Sometimes you're going uphill and downhill, right? Sometimes you're putting your foot down, you want to overtake somebody. Sometimes you slow down because there's a car in front of you, right? Your speed is continuously changing. If you wanted to know the instantaneous velocity at a given time, let's say at t=8, imagine you're driving your car and at the 8-second mark there were a bell went ding and you looked at your speedometer at that instant moment of time. The speed, I should say, the velocity that you're doing at that point is your instantaneous velocity. You got the kind of concept of what they're after, right? Now, your average velocity would be over an interval, right? So I might be saying I'm driving from here to Poolsbo and my average velocity was 42 mile an hour. That doesn't mean I was doing 42 mile an hour every single moment of that entire journey. Agreed? Right? The average velocity is sometimes I'm doing 30, sometimes I'm doing 60, right? But from start to finish, that's what it averaged out at. So instantaneous velocity is what's happening at that exact instant of time. And if you want to find the instantaneous velocity, which we will just call velocity for short, you find that guy. Does that make sense that the derivative would be the instantaneous rate of change, right? The instantaneous velocity. So we had an ugly function, this guy, and we want to find the instantaneous velocity at t=8. So in other words, a is going to be 8. So s dashed of 8 is going to be the instantaneous velocity at the 8-second mark. I have 2 choices. Right, I could go this way, I could go that way. Which one do you want me to use for this question?
The bottom one, because it's a fraction?
Well, it's a fraction. The original formula, whoops, the original formula's got that, so why not? So it's going to be the limit as, I'm going to have to change the variables, so it's going to be t tends to 8. And it's not going to be f anymore, it's going to be s of t, take away s of 8, all over t, take away 8. So that's the one we're using. Do you see the a's become 8? And a minor cosmetic change, right? So let's see what the next line looks like. So it's going to be the limit as t tends to 8. S of t, whoops, let's get our question back, is this guy. So it's 1/2 t squared. Take away 7t plus 17. Take away s of 8. And s of 8 is -7. Because I can now read the darn thing, right? All over t minus 8. So it's going to be the limit as t tends to 8. Well, let's see, that's 1/2 t squared. Take away 7t plus 24. T take away 8. Now, remember we gave you the choice. And the formula that we're dealing with is a quadratic. So it really belongs in the polynomial family. And this one here would have been a little bit nicer math. It doesn't mean I can't get the answer by this method, but do you notice it's going to get harder? And that's because factoring that guy is not easy. It's doable, but not easy. So I could have just said when person did it, oh no, let's do that one. I just want to show you that you can fight your way through this one. But trust me, if you did this one, it would be a lot easier in your brain. So next line. I want to factor 1/2 t squared minus 7t plus 24. It is not a good idea, isn't it, to try and factor anything that starts with a 1/2 t squared. Do you agree? Most of the time that just doesn't end well. So I'm going to pull out 1/2 as a common factor, which means this is t squared, this is -14t, and this guy up here is now 48. Are you okay with what I just did there algebraically? Okay. Now at least I've got a quadratic, right, with numbers in it, whole numbers. So I should be able to factor it. And since it's t squared, I know it's going to have a t and a t in it, which is fine. What about combinations of 48 that when you combine them get you -14? Doesn't that tell me that both the numbers have to be negative? And I'm looking for combinations of 48 that make 14. But there's a clue. I already know what one of them is. I already know what one of them has to be. What does one of these have to be?
-6 and -8.
Right. And one of them has to be -8. Agreed? Because they're going to have to cancel. And I know that's going to happen because that's what always happens. So even if this number was, I don't know, 590, wouldn't you know that one of them was 8 and therefore you could always figure out the other one, right? So it's not going to be hugely difficult to factor it, even if the quadratics are bad and messy. And someone said t minus 8, t minus 6. We can now cancel 1 for 1. And we are left with the limit, and one that's an 8. The limit as t tends to 8 of 1/2 t take away 6. 1/2 8 take away 6. And oh, isn't that pretty? The answer ends up being a very nice number. It ends up being 1. And the units, if you're interested, are feet per second. So if you're asked to find the instantaneous velocity of a function where you're told its position, right? You're told s of t at any given time, you just find the derivative at 8 or 2 or wherever it is it asks you to find the instantaneous velocity. Now, if you wanted to save some time, couldn't you find s dashed of A and go through the same process? And then you could just say, well, when it's 8, I'll plug 8 into the answer. If I wanted to know the instantaneous velocity at 10, I'll plug 10 in, and so on. We're only following instructions here, so we didn't need to do that, but you could. Okay, let's have a look at, I know where I want to go now. Let's do a rock. Question 10. The height of an object t seconds in the air after it has been thrown is given by 15t take away 1.86 t squared. And question A is asking us to find the velocity of the rock. I guess we should say instantaneous velocity, but we just say velocity now. The velocity of the rock at, say, 2 seconds. Question B asks us to find the velocity at t equals A. And then question C says, when will the rock hit the ground? And D says, what will the velocity of the rock be when it hits the ground? Okay. Now I'm going to change the order in which we do these questions. They asked me to find the velocity at a general value t equals A, and they asked me to find the velocity at t equals 2. Would it be, do you see why I might do this one first before I do that one? Because if I do this one, don't I just need to plug A as 2 and I can get that one for free? If I do that one, won't I have to do the whole algebra stuff with the limits? Right, if I did this one first, the whole algebra stuff, and then I'd have to do the whole algebra stuff again, right? So I'm just trying to be efficient. So here's our questions. I am going to do that one. That one works better with polynomials. So question B is going to be the derivative at A. That will get me the velocity. And it's going to be the limit as h tends to 0 of the position at A plus h. Take away the position function at A over h. And so, next line. A plus h, so 15 lots of A plus h, take away 1.86 A plus h squared, take away, put a bracket around it to make sure we get the order right. 15A, take away 1.86 A squared. We're comfortable with all those bits? Next line. Distribute 15A plus 15H. If you square A plus H, you get an A squared, a 2AH, and an H squared. So minus then 1.86 A squared. 2 AH's in that guy gets you negative, God in Himmel, 2, 6, 7, 3.72 AHs. And then you get negative 1.86 H squared at the end. And then you get take away 15A and take away 1.86 A squared. Oh God, that was tight. Okay.
Plus, Professor, the last term is plus 1.86a squared.
Yeah, got it. Yeah. I'm not keen on killing these two guys off and killing these two guys off. So that gets killed off by that. This one gets killed off by that. And now I'm left with a 15H, a negative 3.72 AH, and a negative 1.86 H squared. Just do a little pause there, apart from numerical, because I might have not doubled something correctly, but I hope I did. Would you agree that's a good place to be? All of the top have got H's in them. Now, if I had not, or if you hadn't told me about that mistake, when I did the cancelling, wouldn't one of the cancelling not happen? And I'd be left with, what would I have been left with? 30A. And I'd be saying, why have I got 30A left over? Oh, that should be negative, right? And I hopefully would have found. So the next line is you pull out H as a common factor. And you're left with 15. Take away 3.72A. Take away 1.86H. Do a 1-for-1 cancel. And you now have the limit as H tends to 0. That. And the velocity at A then, S dash of A, is going to be plug 0 in for H, and you are left with 15, take away 3.72A. And that's our formula for finding the velocity at any given value t equals A. So question A asked us for the velocity after 2 seconds. So S dash of 2 would be 15, take away 3.72 times 2. And just check that on the calculator. 15, take away 3.72 times 2, and I get 7.56. And in this question, the units happen to be meters per second. Right, before we move on to the next 2 questions, is it possible for a velocity to be negative? Could I have got the answer negative 7.56? Yes. Those who've done a little bit of physics, velocity is sometimes called a vector or a directional number. Velocities going up are positive. Velocities of things coming down are negative. So if something had a velocity of plus 15, it would be leaving the Earth, right? It'd be going upwards. If it had a velocity of negative 20, wouldn't it be coming downwards? Now, when you say the speed of something, which is not the same exactly as the velocity, the speed is always positive, right? I'm going upwards at 15 miles an hour, that's my speed. I'm coming down at 16 miles per hour, that's my speed. But velocity has a direction to it. That means it's got a plus or a minus. If you go to the right, that's very often considered positive. If you go to the left, that's very often considered as negative, right? So you can have movements left and right as well. So don't talk yourself out of that answer if you get negative 10 and think to yourself, that doesn't make sense. Yes, it does. It's allowed.
So can it ever be equal to 0 then?
It can. What would 0 mean? Practically, if a velocity was 0.
It's at rest.
It ain't moving.
Hit the ground.
Or you smashed into the ground would be another way of not moving, which is what this rock is about to do, isn't it? So question C is not going to involve any of this stuff. Question C is, when will this rock hit the ground? Now, if you imagine this was time and this was the height of the rock, it would probably look something like that. Isn't that the usual kind of thing that you do when you throw things in the air, right? We are interested in when it hits the ground, which means then, aren't we interested in solving when is the height 0? And so we need to solve when is 15t take away 1.86 t squared, when is that equal to 0? And always try and take the easy road. Don't make your life hard. Okay, what could I do to solve this equation? So don't talk to me about quadratic formulas. That would be the hard road. Make your life easy. Just look at what's going on here. What could I do?
Would completing the square work?
Yeah, but you're still making your life hard. Even easier than those.
You want the easiest way?
Can you
Yep.
use the general derivative equation?
No,
Jump
don't
in.
want to do it. That's too
Let me
hard.
look at the
You're just
graph.
solving for t.
Oh, Tess, you said you
root.
could put it into a graph. Couldn't you
It's the
stick
root.
into...
Where it hits the ground on the graph, like the picture you drew where you're pointing to the point.
Mhm.
That point on the graph is where it hits the ground, and so it will be the y coordinate of that point.
Well, it'd be the x coordinate, but I know what you mean.
Oh,
Yeah.
the x coordinate. Sorry.
So you could just stick it in the Desmos, couldn't you? And let Desmos tell you where that is. Or you could pull out a common factor of t. That's what I was kind of hoping to hear. Now, this one is easy. T equals 0, but we kind of can see that, right? It's there. And this one, well, we have to maybe do a little bit of work. Like we have to solve for that. So I would just subtract 15 from both sides. And if you divide it. So the easiest way of doing this would be plug this guy into Desmos, right? This guy up here into Desmos. And then, you know, in Desmos, you can click on the picture and it'll tell you what the answer is, right? Or you could do a little bit of math. Let's see what this one looks like. Negative 15 divided by negative 1.86. And the answer has to be rounded off to 1 decimal place. So to 1 decimal place, 8.06 is 8.1 seconds. Are you comfortable about how we did that? Right. Now, if I had time, which I don't, I would be zooming over to Desmos, wouldn't I be plugging that in? And you know, in Desmos, you can just click on it and it'll tell you what the coordinate of the point is. And it will be 8.06, 0, whatever that says, right? And you'll know it's 8.1. So that's question C done. When does it hit the ground? It hits the ground just slightly after 8 seconds. And now it's asking us, what is the velocity when it hits the ground? Well, the good news is we already know most of what we need to know. Won't that guy tell me the velocity at any value A I like? So to get the velocity when it hits the ground, don't I just need to find out what the derivative is at 8.1, which is 15 take away 3.72 times 8.1. So I'll go to the calculator and I'll do 15 take away 3.72 times 8.1. And the answer I got is negative 15.1 132 meters per second. And that is negative, and that makes perfect sense. Would you agree when this rock finally hits the ground, isn't it going to be coming down the way when it does it? And things that are going down the way have negative velocity, right? Not that they asked this, but see at that point there, what will the velocity be, the instantaneous velocity, at that point there?
Wouldn't it be 0 because it stopped for a moment?
What we may have lost track of here is, isn't this telling us the slope of a tangent line? And the slope of a tangent line also happens to be the velocity of the thing. Isn't it nice that those two, one's geometric, right, the slope of a line, and the other's physical velocity? Would you agree that's horizontal? Now, if you think of a rock being thrown in the air, in fact, some basketball players seem to break the law of physics. When they jump in the air, isn't there a kind of instant moment of time where it looks like they ain't moving, right? They're like floating. Technically, isn't their velocity 0 at that highest point just before they dunk it in, right? You're looking at a practical example of, you know, a moving object going up and then coming down. In this case, it would be a basketball player inside of a rock. Can I call that, right? Which means if I know where you are, if I know your position function, at any given point in time, don't I know your velocity as well? Because I will find, you know, whatever it is, I will find S dash of A, right? And then if I want to know what the velocity is at the 10-second mark, if I want to know the velocity when it hits the ground, if I want to know any type of velocity question, we are good to go. And that is the end of that question. So moving on, let's do some more velocity questions. So that's kind of the theme right now. Let's suppose that I have a position function that is that guy. And I want to find the velocity at t equals a. In other words, they've basically just said, find that, right? So if they give you a function and ask you to find the velocity at t equals a, they're saying find this. Now, we talked about this yesterday, that you can theoretically use either formula in any situation you like, but sometimes one formula just makes the math a lot nicer than the other formula, right? Top one or bottom one? What should I use for this one? Top formula or bottom formula? What should I use for this one?
Bottom.
Right. Fractions are better done with this guy. They just are. Right. So S dash of A is going to be the limit as t tends to A of S of t, take away S of A all over t minus A, right? I've adapted the formula. F is now called S, X is T, and everything else is pretty much what you'd expect. So far, so good. So we're going to be finding the limit as t tends to A of this function. Take away S of A is this function. Now, although that looks bad, trust me, it looks even worse if you did that. Now we've came across this fraction with fractions in it issue before. And the way that we kind of got round that problem was we multiplied by a special version of 1, not the conjugate. There's no square roots here, right? But
T
we
squared,
did
A
multiply.
squared?
Say it again.
Is it T squared, A squared? Over? No, I tried.
I'll give you the A squared. I like that. So you're half right. What else?
2?
Mm-mm.
Okay.
2's not a problem, actually. Focus on something else that is a problem. Right. A squared's a problem, right? It's on the fraction. Isn't T squared the problem?
Oh, that's what I originally said.
What was it? I didn't catch you. Sorry.
Yeah, sorry, I'm a mumbler.
I think it's just my age. Right. A squared, T squared. Are you comfortable with that, right? If that was, I don't know, if that was 4 and this was B squared, it'd be 4B squared, right? I only care what the bottom is doing. The top really doesn't matter. It's fine. The top can be anything. In fact, couldn't the top be T and it still would be okay, right? I wouldn't worry about that. Now, that should change the question algebraically. And so A squared, T take away A, that's fine. These two guys times him will leave you with 2A squared. And this guy times him will leave you with 2T squared. So at least there's no more fractions, right? But we still have a fair amount of algebra, right? We still have a fair amount still to do before we can finally find this limit. There's nothing to do on the bottom, so just leave it alone, which is kind of typical. What could you do to the top? Numerator.
Cancel out the squares. A squared for A squared and T squared for T
Oh,
squared.
not allowed. Algebraically not allowed to do that. Can only cancel factors. That minus stops it being a factor.
True.
So what else could you do?
Factor it.
Okay, I'll pull out a 2, which is the first factor. Not sure I need 2 lines, but I think it's always a good idea when, especially if you're doing notes, to put in every line. Right. Do you recognize A squared minus T squared as a difference in 2 squares? That's typically what we call that, which means it can factor. What does it factor as? What do you get out of this guy?
Isn't it like A plus T? I don't remember the other one.
A minus T.
A minus
Right.
T.
Between us all, we got the pieces. Yes, A plus T, A minus T. That's what you get when you do a difference of 2 squares. So I'll move over to here. And I should be cancelling right now, shouldn't I? And I am. And we've seen this at least twice now. So hopefully every time you see it, it becomes a little bit more comfortable. Who on the top, numerator, cancels with who on the bottom?
A minus T and T minus A.
And what happens when that combination gets cancelled?
Transfer the negative.
So we now have a negative answer, essentially, right? So we have a negative 2 lots of A plus T all over an A squared T squared. Right? We go with that. At this point, we can now, oops, I forgot to put my limits in. I'm very forgetful. There we go. At this point, can't we now replace the T by A? So it's negative 2, instead of A plus T, A plus A. And on the bottom, A squared, instead of times T squared, times A squared. And now we're into style points, making things look nice. A plus A gets me 2A, and negative 2 times 2A gets me negative 4A. And A squared times another A squared gets me A to the 4. Right, it's looking a lot prettier than it did a while ago. What does that simplify to?
-4 over a cubed.
Right, we just basically cancel an a. Agreed? Now that I know this fella, which is essentially telling me the velocity at any given time t equals a, the next question goes and says, oh, I'd like to know the velocity when t equals 1. I'd like to know the velocity when t equals 5 and whatever, right? If you want to know the velocity when time is 1, it's that guy. It's -4 over 1 cubed. So it's -4 meters per second. If I want to know what the velocity is at the 5-second mark, it would be -4 over 5 cubed, which is -4 over 125 meters per second. And we kind of like answers to be left as fractions. If you start turning some of these into decimals, don't they become really ugly and not very easy to understand? Are we beginning to feel comfortable that if I tell you s of t, that you can find its derivative? Right, s dash of a. Right, we've done a lot. What have we done? We've done a square root one, haven't we? We've done a fraction one, we've done a polynomial one, right? They're the three main situations that you're going to deal with. Any more questions before we move on? Are we good?
How does this differ from in our first section where we were doing the velocity questions there?
I don't think it differs much at all.
So could we solve the first section's questions the same way as we solve these?
No, because they don't want you to. They want you to do it. They want you to get practice at doing it all sorts of ways. I mean, for instance, haven't we been in earlier questions, like in week 1, didn't we have to do it numerically? Well, you notice that we've moved away from numerical to much more algebraic. So you do it by the method that you're being asked to use at the time. Once nobody tells you what method to use, aren't you free to pick any method that makes sense to you? So then you can say, well, I'm definitely doing it this way. This is a lot less work than the other horrible way that we used to do it. In fact, this is not actually the end of the line. I'm going to show you an even easier way to find that guy. But not yet. And when I do show you that easier way, Coral, you are not allowed to ask me, can we do it that new easy way instead of doing it the way we did yesterday, right? Or whatever.
I'm just thinking I struggled so much with that part of that first section, but this is making sense to me.
Isn't that nice when that happens, right? The later stuff is actually much more useful than the awkward way that you had trouble with, because it is kind of awkward, isn't it? There's a lot of numbers, a lot of things you have to deal with. The more algebra something gets, I think the cleaner it gets, right? So the next question is actually not like anything we've done. Hopefully it's not too horrible either. It looks to me like the kind of question, although I've never taught physics in my life, and you probably should never ask me to, it's not my thing. But have you ever seen a chart that looks like this, which is a position time function? Right, so I'm seeing some nods because is it physics you've seen it, Robert? Is that where they
Yes.
come from? Right.
Yeah.
So basically this diagram, this chart is telling you how the object is or where the object is at any given time. Now, whenever you see a straight line going upwards, and we always measure it from left to right, when you see it go upwards, that would be an example of someone moving to the right, right? They're moving to the right. When you see a horizontal line, isn't that person just stopped for a while and had a little rest? And when you see the line going down the way, as we have here, wouldn't that be an example of a person who was walking back home, right? So can you imagine this was a story? Somebody left their house and they walked there, they get a little rest. They walk back towards their home. Maybe they say, oh, I forgot my keys. But before they got to home, because home would be 0, right? Oh, wait a minute, they're in my pocket. So you spent a little few moments and you get it out your pocket and you say, okay, back to walking away out from my house, right? Made that total story up. But, this is telling you the movement of an object through time. So when they say here, when is the object moving to the right, only look at slopes going uphill. Would you agree there's a slope from 0 to 1? Check. And from what, 4 to 6 seconds. Does that make sense now? When is the person moving to the right? Uphill means moving to the right. Downhill means moving to the left. So when is it moving to the left? Okay, tell me an interval when this object was moving to the left.
2, 3.
Okay, so I would just click on that. Give me an interval when it is at rest, which is just another way of saying not moving.
1, 2.
And the other one?
3, 4.
Okay. So far, so good. Now, the next bit is going to be a bit awkward. We're going to actually sketch the velocity function, which is what is the velocity of this moving object at any given time, right? Instantaneous velocity. Now, what it ends up being is the slope of the curve, or in this case, line, at that given point. So here goes. From t equals 0 to t equals 1, would you agree that it is a positive slope? And if you do a little 3 boxes by 1, would you agree that the velocity from 0 to 1 second is 3 meters per second, right? The slope of that line. So from 0 to 1, it has to be 3 seconds. So you click on this guy, you click on there, and you go from here to here, it's 3 seconds. Okay. Now, next part of the journey. From 1 second mark to the 2 second mark, wasn't the person not moving, right? They were stationary. And the velocity of stationary is 0. So I go down here and I go from the 1 to 2 second mark, it was 0. So I click on this and I go from 1 to the 2 second mark, it was 0. Are you comfortable with what I'm doing here? Now you might say, but that looks weird. There's a jump from here to here. Would you agree? There is a jump from here to here. And that's what it is. Nothing wrong with that. And then it goes, oh, isn't this a downhill journey? And if I do a quick rise over run, I believe that's -2. So when we go from here to here, it's -2. Now, I'm clicking on that and I'm pretty comfortable. I'm getting nice numbers. But if you want to be absolutely sure, click on this guy and you see it'll tell you the coordinates of where you start and finish. Let's just pretend that I was a little bit out. Okay. Now, if you look at my picture, can you see it looks a little bit out as well? Now, you can fix it 2 ways. One way would be just to go back there and put in the number -2. The other way is keep your mouse clicked on it and then just drag it down. And oops, I didn't fix it. Oh, go away and now fix it. There, fixed it, right? Couple more to do and this guy's over. From 3 to 4, it was 0. So from 3 seconds to 4 seconds, it was stationary again. And then for the last 2 seconds, from 4 to 6, it was going to the right. So what would that be? 2 by 2. So that's rise of 2, run of 2, that's a 1. And so for 46, it would be that guy. So if you've never done physics, do you feel comfortable that you should be able to do something like that? And hopefully you will do physics. It's a cool subject, a lot of math and physics. Right, next question. Here is an example of a position time curve. And this is showing you two people running the 100-meter race. And it's slightly artificial, but let's pretend it was really accurate. Person A is that red line. If you were describing that person's run, wouldn't you say that person somehow, from the minute the gun went off, they hit the road running, and didn't they run at the same speed, start to finish? I've never seen any runner do that. The ones I see on TV, don't you start off slow and get fast? Right. It takes time to build up speed. Isn't that more realistic, which is what B is? Now, in this race, if you were going to describe it, wouldn't you describe A as constant velocity or constant speed for the entire journey? And wouldn't you describe B as starting off slow and building up speed? Now, looking at that diagram, did anybody win, or was it a photo finish?
It was a photo finish.
Although they don't mark it, do you know that number there is 100 meters? So at the 100-meter mark, didn't both of them take, what's that? It's 4, darn it. I wish they'd put the middle numbers in. 14 seconds, right? So
What?
14 seconds, they both finished 100 meters at the same time.
Oh,
Does that make sense?
yeah.
Right. So it'd be a photo finish, I guess, right? Sometimes you get dead heats, but most of the time, don't they win by ridiculous 0.001 second? And you think, if that guy had a longer nose, he would have won. You know, it's that tight. Seems unfair when that happens, but that's what they do. So you should be able to answer those questions. I think we're pretty close to being finished. I just want to make sure I've covered everything. Oh, can you recognise doing an F-A question? And then plugging in 6 or plug in 6. Just doing a pure F-A.
We have that, you called it an ugly question yesterday.
Oh, yes. Thank you very much. Where was that thing? Help us out here. There was an ugly question. I said, look, I want to do this. Where was it, guys?
I think
Was
it was
it-
4.
It's
I think
4.
it was. So perfect. We've got time to do it as well. So for the last thing we're going to do today is we are going to find the equation of the tangent line to that ugly fraction at that given point. I'm so glad you've done that, because if she didn't do that, you are not going to have fun doing the homework question. Right, so the one I'm doing, it'll be a miracle if it's the same numbers, but it will be the same type. To me, the ultimate, oh, I guess I should be consistent. The worst questions to deal with, in my opinion, are fractions. I think quadratics are probably the easiest to do. Square roots are probably next, and fractions tend to be the worst. So we are interested in finding the equation of the tangent line to this curve at that point. And they're calling it y equals, but I kind of jumped the gun. I would call it that, because it makes more sense for the formula. Since this is a fraction, I am going to go with this guy. Now, this guy is going to be really ugly, but this guy would be even more ugly, right? So you're going to say, oh, no, that looks horrendous. I would probably do that one. Trust me, if you did this one, it would be like even, you know, it's like having 200 zombies in the horror movie and you do the other way and it's 1,000,000 zombies, right? It's not going to end well, right? You're going to get killed. So we are interested in 3. So I want to find the derivative at 3. It's going to be the limit as x tends to 3 of f of x take away f of 3 all over x minus 3. Are you comfortable that you get the 3, the a from the x coordinate, right? You know, though they don't say a is 3, that's how you know it is. That's going to be the limit as x tends to 3 of this fraction take away f of 3, which happens to be negative 8. How do I know it's negative 8? Because that guy. Or if you don't believe me, plug it in, and that better be. Yeah, it is. And on the bottom, we have that. I'm going to take this as slow as I can because of the ugly math. Are we okay so far? You're all comfortable with all the bits that we've got, why they're there and where they came from, right? Now we have that classic problem that you get with fractions. Isn't there a fraction on the top line that we do not like? And in the past, we've multiplied the top and bottom by what? A squared, t squared. I think we did that today. But in previous questions, haven't we done 4a over 4a and things similar to that? I'm not going to change that rule or that process. I'm just going to have to figure out what special version of 1 will get rid of this fraction's denominator. It's kind of looking at you. You just have to know where to look. What shall I multiply by top and bottom to make this fraction, this bit here, go away?
X minus 4.
Great. Right, now that you've seen that, does it make sense that that would be a good choice? So go over here because I'll need a little bit more room. Is it living up to being ugly? Right? It's at least doing that. So big row on the bottom. These two guys I'll just write down. This fraction times x minus 4. I'll actually do that as some working at the side. So if you take the fraction x plus 5 over x minus 4 and you multiply it by x minus 4, don't the x minus 4s essentially cancel and you're left with x plus 5? You comfortable with that? So x plus 5. Add, right? If you take 8, which is the next term, and you multiply that by x minus 4, don't you get 8x take away 32? So 8x take away 32. Are you comfortable with those two guys? That guy times x minus 4, that guy times x minus 4. So we are now looking at that line. What should I do next algebraically?
Collect like terms.
Okay, 8 and 1 make 9, so that's 9x. And that guy get me negative 27. So far, so good. Okay. Yeah, it's a new question, you know. You have to adapt. What do you think I should do next?
Pull out the 9.
I like your thinking. And the minute you pull out a 9 as a common factor, don't things become a lot clearer? Right? before, not sure where we're going here, pull out a common factor. Yep, I know where we're going to go. I hope you agree. The next stage is cancel, cancel. 1 for 1. We are now looking at, need a bit more room here. The limit as x tends to 3 of 9 over x minus 4. Great. And at this point, we can replace the x with 3, and we get the answer -9. And to remind you what the question was find the equation of the tangent line at that point. So I now know the slope of the tangent line. It's -9. I also know the point that the line is going to go through. And what will I do next?
You'll do that slope to point equation or whatever it's called.
Yeah, point slope equation. And obviously, that's the x1, y1 thing. And you have y take away -8 is -9 x take away 3. That becomes y plus 8. And that becomes -9x plus 27. And this becomes -9x. Take away 8 from both sides. I believe we get that. Right, hold on a moment. While I'm doing this, put your last name down for attendance. And I should be able to have Desmos. I'm running by then. Okay. So you're doing attendance, and we are going to be doing Desmos. And Desmos is only to check. So the curve was the ugly fraction. What was it? X plus 5. So I guess I should put a bracket around it. That way, Desmos will know it's x plus 5. And on the bottom, put a bracket around it, and it was x minus 4. So, as you'd expect, it's a pretty ugly thing. Then the tangent line, the point that we were finding the tangent line was 3, -8. Let's put that point in. There we are. Do you see it down there? And then the equation of the tangent line, provided I didn't screw up, is -9x plus 19. Oh, am I good or am I good? Does that look like a tangent line to you guys? And we are done.